GRCon, New Radio, a lot of this is due to Matt Ettus' work, and so there's really no GRCon without Matt's talk. Really nothing else to introduce Matt really except that this segment.
So, can everybody hear me? Is the microphone here? So, just a quick who am I? I joined the New Radio project very soon after Eric Blockman started it back in 2001, and started designing the USRP, the original USRP one, in 2003, really because we had New Radio and we had no interesting hardware to use with it, and we were doing things like sound cards and email boards, and it just was limited. So, I designed USRP not as a product, but as something I wanted to use and experiment with. And it turned out there were other people who were interested in that. So I started Ettus Research in 2004 to continue developing and produce and sell the USRP. So that's 11 years ago this month, actually. And 5.5 years in, we were acquired by National Instruments, and it's now 5.5 years since then, so it's actually equal halves of pre-acquisition and post. And we remain committed to the vision of building low-cost, easy-to-use software radios to enable our users to exciting new things with them. I'm really excited to be here at, I guess it's our 5th annual New Radio Conference, and you know, it's amazing to see this huge room. I've never presented on 4 screens in parallel before, never more than 2 actually, so this is a big step up. But I remember our first year was in Philadelphia, and we were in a classroom at University of Pennsylvania. There were, I think, 54 of us in a classroom that was supposed to have less than 50 people in it, and we were sort of packing on little desks. And that was a huge success. And every year when it gets bigger, I'm always continually amazed. And so I think it's really a testament to the community and what we've built and how powerful and compelling it is. So really, congratulations to everyone here, because together we've created something really amazing. So this was the original USRP story. This is actually a concept I put on a slide back in 2002 and tried to convince somebody else to build it. But the basic concept today is the same. I mean, we have more antennas. We don't have just USB 2. We have a bunch of different interfaces. But it's really a similar concept where we have a general purpose computer and then an interface to some higher speed device where you do your actual interface into the real world. And so now we're really in our 3rd generation of USRP devices, and so I'll just quickly go through those. They've been out for the first one, the X300, was our first 3rd gen device. That's out for about a year and a half now, The basic concepts behind the devices, or the goals behind the devices in the 3rd generation, are easy integration of the multiple processing paradigms. In particular, we have much bigger FPGAs than we used to. The original USRP 1 was so small it had no actual hard multiplier units. You had to use FPGA fabric if you wanted a multiplier. And a decent sized multiplier took up about 20% of the fabric. Today we have the devices with up to 1,600 DSP units that are multiply accumulate systems. And so with this growth, this Moore's Law kind of progression in FPGAs, it's important to be able to take better advantage of those that fabric. And so I'll get to it a little later. We have our RF network on chip architecture, which really makes it a lot easier to use big FPGAs to do your signal processing in the FPGA. We also are concentrating on very high bandwidths, wide frequency coverage, and massive MIMO scalability. For those of you who were here yesterday, you saw in Ben's presentation a picture of a 100-way MIMO system built out of our 3rd gen USRPs. And so that's really an exciting area of research, and we're excited to be a part of that. So the X300 and X310 have been out for about a year and a half now. They give you 160 megahertz of RF bandwidth on each of 2 daughter boards with high-speed APs and DAs. It has a 10 gigabit Ethernet interface, is the most popular one for use with that device. It also has PCI Express if that works better for your application. Huge FPGA with up to 1,540 DSP units. Onboard RAM, and a lot of features for a high-end device. And so you're able to stream over 300 megahertz of bandwidth on each gigabit Ethernet. So you can do a lot of processing in your host computer if it can keep up with this fire hose of data. But again, RF NOC and FPGA processing enable you to do data reduction within the device, so you don't have to deal with that high sample rate in a general purpose processor. And so this is a picture of the X300, and then just show the front and back so we get a better idea of what the ports are. You have RF for one daughter board, and then for the second, so you get 2x2 MIMO out of the box. You have auxiliary controls for external amplifiers, filters, antenna switches, that sort of stuff. And this is nice. If anybody's ever done development with Xilinx FPGAs, you often want to use chip scope and you have to use this JTAG dongle in order to debug the FPGA. Well, we've built that dongle functionality into the device, so you just connect the USB cable straight in, and you have direct Xilinx compatible access to chip scope, JTAG device, and all the other tools that you normally would have to have that external dongle, so you don't have to open the box or anything. On the bottom, we've got power, the dual 10 gigabit or 1 gigabit Ethernet ports, reference in now, and then PCI Express if you are using that. So inside, you've got your 2 big daughter board slots here, and then an FPGA center under the heatsink along with the DRAM. And so you can see an X300 in our booth as well. It's running. I think it's running an LTE base station, a 2x2 MIMO LTE base station, and so there's a lot of really great applications that have been built on the X300. And if anybody has any questions on the X300, or I'll move on to the next step. Okay, great. So the other major product in our 3rd generation of devices is the E300, which is an embedded device. And so the E300 family, the actual shipping ones are like E310, E312. These devices are completely self-contained. So you have a Linux computer running inside it, so you don't need an external computer. And they use the Zinc processor, the Zinc chip from Xilinx, which gives you a dual-core ARM, along with a big programmable logic area. So this is the equivalent of your laptop plus your other USRP combined into one box. Now the processor is not going to be quite as fast as what's in your laptop, but it is sort of a smartphone class processor. So there's quite a lot of computation that can be done in those devices. So the E300s have an RF front end that uses the Analog Devices 809361 chip. This is an incredible chip. It gives you 2x2 MIMO in really one small piece of silicon, and it gives you a 70 meg to 60 frequency coverage with a lot of bandwidth. And so we've augmented that in the E300 with RF filter banks, and that allows you to operate in very strong signal environments, as well as avoid transmitting harmonics and the like, so you can just stick antennas directly on these devices. So if you haven't seen it, it's roughly cell phone size, a little bigger. Again, you can see a bunch of them in various configurations in our booth out there. It has Ethernet, it has USB, so you can put it on the network. And you can also connect anything that you really can connect to any USB port on a Linux computer. You can connect to this. So if you want to connect an LTE modem or a flash drive, or basically anything you can get a Linux driver for, you can run with this. So it's quite expandable. It has GPS built in, and it synchronizes clock to GPS. stereo audio in and out for push-to-talk applications, and it has a 10-axis IMU for UAV type applications or walking around, doing inertial measurements. And so really, we look at this as a software-defined cell phone without the touchscreen. So anything you're likely to find in your cell phone is in this. So it's a small enclosure that's a little bit thicker than a cell phone and runs full Linux distribution, as I said. Have, of course, good radio, UHD, USB expandability. So, as I said, flash drives, Bluetooth, LTE modems, that sort of thing. You can also add a display and keyboard, and so you could run things like GQRX or Phosphor and have a Spectrum display and sit on and use it really just like any other computer. You can check your email on it, run Firefox or whatever you could run on a Linux machine, you can run on this. But really, its reason for being is that you can deploy it in an embedded way and not have to have a separate computer, just deploy radios. So this is a picture of it. So on the front we've got transceiver inputs and outputs, so it's 2x2 MIMO. We have synchronization input, which is either 10 megahertz or PPS or any signal like that. Or you can use the GPS for synchronization and you connect a normal standard GPS antenna to this. There's a micro SD slot, that's where the operating system lives. And here's an audio headset connector and the power button. And then on the back, you have dual USB ports. You have your gigabit Ethernet interface, power connector, and a console. So you can just do a serial port console and for debugging and setup and the like. So that's a fully standalone device. This is the inside. So the E300 motherboard has basically everything but the radio on it. There's another board that goes on top that has the radio. So here you see the zinc chip, Ethernet, USB, Ethernet PHY, USB PHY, battery controls, RAM, more RAM. This is GPS, SD card, power, audio, and so it's a very densely populated board with a lot of cell phone style design in terms of using very small, very low power components. So we see E300, which has been out since December, I guess, was when we shipped it first, so it's still a little bit less than a year now. We see a lot of use in mobile networks, research test beds, UAVs, spectrum monitors, sensor nodes. Starting to see some people use it as handheld communications, signal analysis, test equipment, you name it. And really, this device is I look at it as sort of the holy grail of software radio. Ever since I've been involved in software radio, which is about 15 years now, people have been saying, yeah, but when am I going to be able to carry one around in my pocket and use it, a software-defined cell phone, and just be able to do anything with it in this one device. And it was always, well, that's about 10 years away. And so we finally got there. And I think this is really going to open up a lot of new applications, a lot of new capability for SDRs. So any questions on the E300 or I'll move on to, okay. So, for our devices that have daughter boards, which would be the N series, the N200, N210, X300, X310, we introduced a new daughter board that I think we started shipping back in March, so it's a few months now, called the UBX. And this daughter board covers really the full frequency range that most people are interested in. It does 10 megahertz to 6 gigahertz, operates very similar to our traditional WBX, SBX, CBX daughter boards, in that it's a full duplex transceiver with direct conversion, it's available to two versions. One's 40 megahertz in bandwidth, and the other is 160 megahertz. The 160, of course, only works with the X300 series to handle that much bandwidth. Great receive performance, great transmit performance. It's fully shielded, and we have complete characterization of this online. So all of the RF performance characteristics you care about, there's a PDF that has them all measured at every frequency and at every given point. And this is what it looks like. This is the 160 version. With two of these in an X300, you get dual 160 megahertz channels, 2 transmit and 2 receive all simultaneous. So 640 megahertz of total bandwidth if you look at it like that. And of course, it's MIMO capable and phased array beamforming capable as well. So you can do carrier phase alignment and things like that. So that was an overview of these sort of existing third generation products. I'm going to talk a little bit about RF NOC now. For those who haven't heard about it, RF NOC is a complete system for developing signal processing applications in FPGAs. And it's really a distributed computation system that is network transparent, and it works across large arrays of FPGAs, not just single ones. And we really see it as a way to make it very easy to add FPGA acceleration or even entire designs in the FPGA for SDR, so that you don't have to use a host computer, you don't have to deal with operating system latency and all the variability that goes in a general purpose computer, and the extra latency and all that sort of stuff. So RF NOC is a very powerful way of both easing your development and speeding up the processing for SDR. It's fully accessible from GRC, so within VIN Radio. You can also use it without VIN Radio, just directly from UHD as well. NOC Script is a recent advancement that we've released that makes it a lot easier to support new blocks, really reduces the amount of code that you need to write. Both E300 and the X300 support this, as well as all of our new third generation devices, which will be coming, will support RF NOC. There's a growing library of blocks, and another new development that we'll probably get into in some of the other talks is that we have enabled Bravado HLS support. So Bravado HLS allows you to program in C or C++ and compile directly to the FPGA. By wrapping that into RF NOC, you can now just write function. You can write your algorithm kernels in simple C and C++, and that can be wrapped into an RF NOC block without any additional code, and have it instantiated in the system. And so that's a very powerful way of, again, easing your development for FPGAs. That's really been our goal from the beginning. When I started out in SDR, you had to be an expert at so many things to get anything useful done. You had to understand OSs and multitasking and signal processing and FPGAs and A/B converters and hardware and all these things. And over the sort of 10-year or 12 or 13-year arc that I've been involved with radio, we've been progressively reducing the sort of extraneous skill sets that you need so that you can just concentrate on your application, your comm system, and your expertise, and not have to worry about becoming an expert in FPGAs and an expert in a million different tool flows. And RF NOC is really the next step in that, so that you don't have to really know anything about FPGAs at all at this point, other than how to install the Xilinx tools in order to be able to productively use them for software radio. On the bottom here is a picture of a very simple flow graph in RF NOC. So this would go from the radio to an FIR filter to an FFT, and then come into the host and do complex to mag squared, and then plot it as an FFT plot. So very easy, it's transparent. This flow graph is in VIN Radio, and it has both FPGA-based and host-based processing, and it includes a transfer over the network in between them. And you don't have to express any of that. The system figures that all out for you. So for those further who are more interested in RF NOC, we've got an overview and introduction tomorrow in the main session. Right after that, there's a half-day hands-on RF NOC tutorial that is completely full and oversubscribed at this point. So we're trying to figure out options to get other people access to the same material, but for the 26 or 28 people who made it in, I think you'll really enjoy this presentation, and you'll be quite proficient in RF knock at the end of it. On Thursday, Sylvain will be showing RF knock phosphor. So phosphor is everybody's favorite eye candy in computer radio. It's a real-time spectrum analyzer, and Sylvain has ported that to the FPGA in RF knock. So now you don't even have to waste CPU cycles on that, and it allows small embedded devices to be able to do it as well. So that'll be very exciting. That's a real practical application. And also on Thursday at noon is an OFDM in RF knock presentation, and you'll see how a full OFDM comm system has been built within RF knock, all in available components. And for those who want to dive deeper into RF knock and want some formal training, Coordinate Labs is going to be providing courses that include RF knock. It's in development, but I think October is when they'll start to be available, so you should talk to Jonathan about that. And I highly recommend his courses. It's a very quick way to get up and running and very proficient in computer radio and soon to be RF knock as well. So, new product announcements. The first is the V200 Mini, and I'll flip to the picture first. This is a business card size radio. The functionality is very similar to the V200, which has been available for a little over 2 years now, but we've shrunken it to the size of a business card, including the SMA connectors. It's that size, and it has the same capability, so it's a single antenna, 70 meg to 6 gig, with a USB 3 interface, and it's completely bus powered, so you don't need any separate power. So just one cable and an antenna, and you hook this up to your computer, you have SDR. It runs new radio, of course, and UHD, and if your application is built around any other user, including the V200, but not limited to that, you'll just be able to download the latest version of UHD, plug it in, and you'll get fully functional SDR without having to change anything in your application. So the specs on this, it's 70 meg to 6 gig based on that same analog devices chip, which we use in E300 as well, and V200. It has a Spartan 6 FPGA, USB interface, and lots of bandwidth. For those who are interested in this in higher volumes or for deployment scenarios, we also have extended temperature and big FPGA versions available on this. So those won't necessarily be on our website, but you can contact us about that if you're interested in either of those. So then the E312 is our next big product we're announcing. It's an E310 with the battery built in, so you can see the enclosure is a little bit thicker. It's about 3 or 4 millimeters thicker than the other one. And this has a full 3.2 amp hour lithium-ion battery and full safety certification. So you can walk around with it now in your pocket, no external power source, and this software experience and the rest of the hardware is all exactly the same as the E310. So your apps will just run on there. The battery is accessible from the operating system, just like the battery in your laptop. So if you're running the GUI, you can get your little battery green monitor. It will notify you when the battery is running low. You can query the charge state, how much current is being drawn at any time. We've got a kernel module to integrate all that stuff. And so really we've tried to make the experience as smooth as possible, and it just looks like a battery on your laptop. So both the V200 Mini and the E312 will be available in September, and so they're just about to be up on the website, and you'll be able to order those very soon. Yeah, so the V200 Mini is the same price as the V200, so it's $675 for the US list price on that. And then the E312 is $200 more than the E310, so it's $2,900. Okay, so those are the upcoming products in the short-term future. I just want to talk about some that are a little bit further out. This is like a Q1 kind of time frame. It's a new daughter board called Twin RX. So it's a receive only, but it is dual receiver on one daughter board. So in an X300, if you put 2 of these in there, you would get 4 receive channels, which means you could, in one rack unit, you can get 8 separate receive channels. It's 80 megahertz per channel. And each of the channels is independently tunable, or they can share a local oscillator, for phased arrays. So you can do very quick phased arrays. Because there's also extra local oscillators, you can ping pong between them very fast, and so it can do extremely fast frequency hopping. Very, very high sweep rates if you use that. Very high dynamic range radio. It's actually a super heterodyne architecture, and that's what enables us to get 2 on one daughter board. It has full filter banks in the front end for pre-selection, and so we really see this as an ideal daughter board for use in spectrum monitoring and spectral detection sorts of applications. You can rapidly switch from 4 channels, each on an independent frequency, to you find a signal of interest, you can rapidly switch the other 3 channels over to that and do a phased array to find the direction. So there's a lot of really interesting capabilities with this. Very low phase noise, high dynamic range, and a lot of flexibility. And so we're thinking early Q1 release on this one. And actually, the other one, somehow I lost the slide on it, but this is what we're calling E313. So this is an E310 or an E312. You can use it with the battery as well if you want battery backup. In waterproof outdoor enclosure. So this is IP67 rated. You have your E310 in there. You have some lightning protection and a power over Ethernet adapter. So you put this up on a pole and mounts on the side of the building, and feed it Ethernet with power over Ethernet, or you can just use regular power, and you have access to USB, so you can add a Wi-Fi or an LTE dongle for backhaul. And then on top we have the 4 antenna ports, as well as the a GPS antenna port. And so this will be fully waterproof and mount on poles intended for outdoor ruggedized sorts of use. And in addition, there's also another version of that which will have four-way receive, so no transmit, quad receive, and that's also intended for spectrum monitoring and signal detection, direction finding sort of use as well. And so the outdoor enclosure we're looking at late this year, early next year, sort of time frame on that, and the four-way receive we're looking at early next year. Any questions about any of those? Yes.
Do you have any specs on the temperature range that the enclosed version can handle? Sort of the upper and lower limits?
Right. So we're still in the process of doing that testing, but the goal is that you can put it out in the sun in a in a very hot area of the world and not have to worry about that. It actually dissipates very little power in it itself, and the enclosure is like large heat sinks, so we shouldn't have problems with that, but we're still in the final measurements and certification on that. But yeah, the goal is rugged specifications, waterproof and extended temp and all that sort of stuff.
Price point?
We don't have a price point on the enclosure version yet.
When can we get a data sheet on the Twin RX?
The data sheet on that will come around release time, so Q1.
Okay.
Yes.
Any plans to support the RX not the B series?
So the B series really has FPGAs that are too small to be practical for RF knock. It's not impossible, but it's likely not worth the effort. You wouldn't be able to put much in there.
One more. For the RF knock, I know you put a proposal. Is there going to be a standard RF knock in which goes to the FPGA?
So we do have a standard image, and it has, I think it's FIR filter and FFT, and just a selection of the commonly used stuff. But the real plan is that you pick what you need, and it builds the image for you. And actually, there's a booth here from a new company, and I think they're definitely worth going to talk to. They have created the ability to rapidly build those FPGA images. So normally you build an FPGA, on a fast computer, and it's like an hour plus. They have the ability to build with RF NOC, build in different RF NOC blocks in under 1 minute. And so it now becomes practical to pick the blocks you want in your flow graph, click a button, it builds you the FPGA live, and then runs. And it's really incredible, and really excited that it's Consolidated Logic, I guess is the name, and so it's you should definitely go talk to them. They have gone a long way towards solving the compile time issues that FPGAs have long suffered from. Yes.
With the B200 Mini, so I know, I think I saw that it has an external clock reference input,
Yes.
maybe PPS or one or the other.
One or the other, yeah.
Okay, so is there a way to interface with the GPS chips so that you can do like timestamp line stuff?
Yeah, so that port, the sync port, which has an SMA, can either be 10 megahertz or 1 PPS, or actually any sort of frequency you want, since we have a digital PO level in there that we run. If you want to directly interface to a GPS, the GPIO port can be used, and you could do basically you could do a UART on there and talk to the GPS. You could use another pin for the PPS, and then use the front connector for the 10 megahertz. And it's really flexible. They're all basically just pins connected to the FPGA, so you can do that. In order to keep it really, really small, we didn't put the direct GPS PO on the board, but you can connect to that and do that. Yes.
Do you know whether that's support that you might try to build in within images that you release, or something that you would have to spin around?
It wouldn't be hard, and we can sort of point you to the way to do it, but we're just probably going to release it with those as just GPIOs, and you can use them as you like. And the standard image will do either 10 megahertz or PPS on the SMA. Yes.
Do any of the Ethernet interfaces support the IEEE 1588 precision time protocol hardware timestamping?
So the one in the E300 does have that capability. We have not used it in any way. We've not, but all the pins are connected, and that's sort of a Linux kernel driver level work, but it does support that. And because it's a software lock, you could use that to lock your reference as well. But you'd have to write some code to do that. So there's nothing in that box precluding you from doing it, but it's not you can't just download the software and do it today. Anybody else? Okay, great. So, so the general path in the future, we've got a bunch more products that I can't quite tell you about yet. But wider bandwidth, higher density, higher frequencies. Particularly if anybody's interested in microwave frequencies, talk to me. We're thinking about some stuff in that space. But embedded processing and RF NOC everywhere, really. And the goal is that, the real goal is that you just have to think about your application. You don't have to worry about where it's executing or what what implementation language it is. You're just able to drag and drop blocks and do what you know how to do best. And behind the scenes, goes to a CPU or a GPU or an FPGA as appropriate, and executes in real time without you having to agonize over the process. And so that's our long-term vision, and I think we're really moving along a lot in that direction. So with that, if no one has any other questions, I'd like to thank everybody for your time. Okay.
It's just a simple question. The RF NOC tutorial, which is a closed, will it be video recorded also?
As far as I don't know, to be honest.
All right.
try and make like slides and everything available, like examples and all. Well, so the last thing was a presentation style tutorial. This is sort of hands-on, look over people's shoulders, but like it's
So like the YSBT presentation is probably close to what you're presenting tomorrow morning. And then the tutorial is, as you said, hands-on. So really, I don't think actually recording that makes a whole lot of sense anyways, because it's going to be very individually directed as far as I understand, speaking for it. As you're doing. All right, any other questions?